Okay, so for the problem we have given, we're now looking at the area of surface generated about the x-axis. We have provided the function y is equal to the sine of x as x goes from 0 to pi over 7. And for the determination of the area of surface generated about the x-axis, we have that s of x, or as of x, is equal to the integral as x goes from a to b 2 times pi times f of x, which will be the sine of x, times the square root of 1 plus the square of dy over dx. And we are soon going to determine what the expression to the derivative will be. And so we have given, once again, that y is equal to the sine of x, and we take the differential of both sides. Differential y goes to dy, that of sine of x goes to the cosine of x dx, and thus converting as a derivative, we have the ratio of dy to dx is equal to the cosine of x, and taking the square of this, we have simply at the square of the cosine of x, and that is going to fill in for the square of dy to dx. And as we take the area of surface about the x-axis, supplying the necessary numerical values for these four locations, we have the area of surface about the x-axis is going to go from 0 to pi over 7, and integrating over 2 times pi times the sine of x times the square root of 1 plus the square of cosine of x dx. Okay, now in the case of the integration that is involved, it's going to be very, very complex. And note that the problem had said to use a graphing utility or computer or some other numerical device to determine just what the area of surface will be, and to the nearest 4 decimal places, okay, that value is going to rest at about 0.8586.